In high school, you've probably spent a semester or more studying trigonometry. In this brief tutorial, I'm going to highlight just the parts of trigonometry that are going to be essential for your physics class. I'll start by reminding you about sines and cosines. Suppose, for example, you have a right triangle and you know that the hypotenuse is length 12 and this angle here is 25 degrees. And suppose your goal is to figure out the length of this side here and the length of this side. Or more generally, suppose you have a right triangle and you know the length of the hypotenuse, I'm going to call that h, and you know this angle theta. And again, given h and theta, how can you determine the length of this side and the length of this side? So here's the main result from trigonometry. This is the result that you're going to use over and over and over again in your physics class. Given a right triangle where you know the length of the hypotenuse, call it h, and you know this angle theta, then the length of this side here is the hypotenuse times cosine of this angle theta. And the length of this vertical side, or the side opposite to the angle here, is the hypotenuse times sine of the angle theta. So the sine and cosine functions allow you to determine for any angle what the corresponding length of this side is or that side is of a right triangle. Now, how do you find the value of cosine of theta or sine of theta for some particular angle? Suppose I said, oh, theta is 17 degrees or theta is 26 degrees. How do you find it? Well, first let's start with cases where we can actually figure it out or determine what cosine of theta is and sine of theta is. So for example, suppose theta is 0. So I want you to imagine that this hypotenuse is kind of swung down so it lies right alongside this base here. So it looks something like this. If the angle theta is 0, the hypotenuse lies along the horizontal like that. So the length of this horizontal piece is just the same as the length of the hypotenuse, namely h. And the length of this vertical segment, namely this piece here, is shrunk down to 0 if the angle theta is 0. So in that case, we can determine that when theta is 0, cosine of theta must equal 1 in order that the length of this side is equal to the length of the hypotenuse. And sine of theta, when theta is 0, must be 0 in order that this length becomes 0. If we have a 30-degree angle, okay, so then this is a 30, 60, 90-degree triangle, then you may remember that if the length of the hypotenuse is h, and this is a 30-degree angle, then the length of this side here, opposite to the 30 degrees, is just 1/2 the length of the hypotenuse. And the length of this adjacent side here is the square root of 3/2 times the hypotenuse. So that's just a fact that we may or may not remember regarding special triangles, a 30, 60, 90 triangle. But if you do remember that, then if you compare this with this, you can see that cosine of 30 degrees, cosine of 30, must equal square root of 3/2, and likewise sine of 30 degrees must equal 1/2. If theta is a 45-degree angle, then you may recall that you have a 45, 45, 90-degree triangle. So if this is the length of the hypotenuse, then the length of this side is the hypotenuse times the square root of 2/2, and the length of this side is the hypotenuse times square root of 2/2. Comparing it to this figure, we see that therefore cosine of 45 degrees must equal square root of 2/2, and sine of 45 degrees must equal square root of 2/2. If you had a 60-degree triangle like that, then you may recall that the length of this side here is 1/2 the length of the hypotenuse, and the length of this side here is square root of 3 over 2 times the hypotenuse. So again, in this case, we can say that cosine of 60 degrees must be 1/2, and sine of 60 degrees must be square root of 3 over 2. And finally, let's imagine that we stretch this angle out so it was making a 90-degree angle. In other words, it looks something like this. Then in that case, the length of this vertical side equals the length of the hypotenuse, and the length of this side gets smaller and smaller and becomes 0 when theta equals 90 degrees. So it looks like this, in which case cosine of 90 degrees must equal 0, and sine of 90 degrees must equal 1. So the point of this is that if you remember certain special angles, you can use those to figure out what the value of cosine and sine is for those special angles. But we're interested in arbitrary angles, not just these special cases. So the cosine function and the sine function, they're valid for any angles, and you can either look up in a table or simply use your calculator to compute the sine of any angle or the cosine of any angle. So once again, here's our main result. You have a right triangle, hypotenuse length h, angle theta, then the length of the side opposite to the angle is h sine of theta, the length of the side adjacent to the angle is h cosine theta. This is our main result. You're going to be using this over and over and over again in your physics class. But let me give you another point of view relating to this. It's giving you the same information, but just a slightly different perspective. And it involves the so-called unit circle. So a unit circle is just a circle whose radius is length 1. So let's say I go to a point on the circle. So I'm going to that point on the circle. And suppose this point makes an angle theta with respect to the horizontal. And suppose I want to know the x and y coordinates of this point right there. In other words, if I draw this little triangle here, I want to know the length of this side, that's the x coordinate of this point, and I want to know the length of this side, that's the y coordinate of this point. Well, this is just a right triangle of length 1. If I compare it to this picture, I see that the length of this side here is simply cosine of theta, while the length of this side here is simply sine of theta. So these two things basically contain the same information. It's just that rather than focusing on a triangle with hypotenuse h, here we focus on a triangle whose hypotenuse is length 1. Now let me show you why this is helpful. Suppose we wanted to make a plot of what the cosine function looks like for all different angles. And likewise, we wanted to plot what the sine function looks like for all different angles. Okay? Well, here I'm showing you what those plots look like, but let's go through it together just to get a sense of it. Let's imagine that theta is 0. So in other words, this black line here is swung down and it just lies right along the x-axis. In that case, theta is 0, so the length of this side is just 1. So cosine of 0 must equal 1. Meanwhile, if this angle theta is 0, then the length of this vertical side here becomes 0. So sine of 0 must be 0, as you see from these plots. Now, as you start increasing the angle, you'll see that theta, or cosine of theta, I should say, is decreasing. It started out here, and as you increase theta, so you're moving this point up along here, you're decreasing the length of this side, so cosine is dropping. Cosine of theta is dropping. Meanwhile, the height of this point, as you swing it around here to larger angles, is growing. So the sine function is growing. The sine function becomes largest when this point swings around and you're at a 90-degree angle. So when you're at a 90-degree angle, which means sine of theta is 1. Meanwhile, when this angle is 90 degrees, so that dark black line is right along here, the x value becomes 0. So cosine of 90 degrees, or cosine of pi over 2, is 0. Now let's imagine that you keep on going. You change the angle so it goes past 90 degrees. So here I've continued to swing this thing around until it's over here. So now here's the new angle theta, which is greater than 90 degrees. What does the cosine function and sine function look like in that case? Well, again, let's draw these triangles. And what we can say is that notice that the cosine function is going to start becoming negative because the cosine function is just telling me the x-coordinate of this point. And when theta is greater than 90 degrees, like it is here, the x-coordinate of this point, you see, is in the negative side, so it's negative. So cosine, once you get past pi over 2, or 90 degrees, starts becoming negative. Meanwhile, the sine function is just this height here. That's still in positive y direction. So the sine function is still positive. So if you exceed 90 degrees, the sine function is still remaining positive. When this point finally swings all the way around to here, so you're at 180 degrees, then you could see that the cosine function now is -1, and the sine function, so that's why cosine at 180 degrees, or pi radians, is -1, and the sine function, when this point is way down here, which tells you the height of the point, is 0. Both of these functions, the cosine function and the sine function, are 2 pi periodic functions. In other words, as you go around and increase theta more and more and more, once you reach 2 pi radians, or equivalently 360 degrees, you're back to where you started, so the value of the function just starts repeating. There are some useful trigonometric identities involving sines and cosines, and I want to walk you through just the basic ones that you'll most likely encounter in your physics class. The first two say that cosine of negative theta is the same as cosine of theta. So for example, cosine of negative 30 degrees is the same as cosine of positive 30 degrees, same value. The second one says that sine of negative theta is equal to minus sine of theta. So sine of negative 30 degrees is equal to minus sine of positive 30 degrees. Let me show you very briefly where these come from. Here's our basic unit circle. Here's a point on the unit circle. And we form a right triangle here. And we know that the length of this side is cosine of the angle. And the length of this side is sine of the angle. So again, when you have this point here that's making some angle theta, the x-coordinate of this point is cosine of theta. The y-coordinate of this point is sine of theta. Okay, now let me consider, instead of going around to positive theta, let me go to negative theta. Suppose I swung this point around and it was down here, so it's making an angle of negative theta. So I'm at that point, and the question is, what are the x and y values of that point? So we'll draw the little right triangle here, and we see that the length of this side here is going to be cosine of negative theta. And the length of this side here is going to be sine of negative theta. But now, just stare at these two triangles here, the red one and the blue one. Notice that if I look at this, the red part where it says cosine theta, and the blue part where it says cosine of negative theta, those two dashed lines here are exactly the same length. So it must be the case that cosine of negative theta is the same size as cosine of theta. Now let me look at the vertical legs of these two triangles, the red one and the blue one. The height of this point is sine of theta. The height of this point is sine of negative theta. But we see that the y value of this point here is just negative the y value of that point there. They're the same heights, but just one is positive, one's negative. So that tells us that sine of negative theta must equal negative sine of theta. This picture shows you where these trig identities come from. Let's look at another pair of trig identities. There's another set that you may or may not remember from your trig class in high school that says cosine of some angle theta is equal to sine of 90 degrees minus theta, and likewise sine of the angle theta is equal to cosine of 90 degrees minus theta. Where do these things come from? Let's again start with the following picture of the unit circle. Here's a right triangle making angle theta. The length of this side is cosine theta. The length of this side is sine of theta. Okay, so I just want you to stare at this triangle, this right triangle, and if this is angle theta, then the length of the side opposite to that angle is sine of theta, and the length of the side adjacent to this angle is cosine of theta. Okay, now, since this is a right triangle, if this is angle theta, then this angle here is 90 minus theta. So now I want you to look at this triangle again, okay? But this time focus on this angle. It's still a right triangle, but the idea is that the length of the side opposite this angle must be the sine function. So it's sine of 90 minus theta. And the length of the side adjacent to this angle here, namely this length, is just cosine of 90 minus theta. But now stare at this picture. We see here that cosine of theta and sine of 90 degrees minus theta, they must be exactly the same. Likewise, if I look at this side here, sine of theta must be the same thing as cosine of 90 degrees minus theta. So this picture may help you remember these two trig identities. Here's another trig identity that you may or may not remember. Cosine of 180 degrees minus some angle phi is equal to minus cosine of the angle phi, and sine of 180 degrees minus some angle phi is equal to sine of phi. Okay, so let's see where these come from. Again, we'll go to our unit circle, and this time I'm going to go around, and I'm going to go around, around, around. I'm going to go to 180 degrees, but then come back a little bit by some angle phi. So the net angle that I'm going around is 180 minus phi. Okay, so here I am. This point here is at angle 180 degrees minus phi. Okay, and if I draw my right triangle here, then I know that the length of this side must be cosine of this angle, 180 degrees minus phi, and the length of this side here is sine of 180 degrees minus phi. Okay, so that's just what we get by looking at the unit circle. Now I want you to change your perspective slightly. Focus on just this little triangle here, where this angle here is phi. Then the length of this side opposite to the angle phi, we know can be written as just sine of phi. And the length of this side here, adjacent to the angle phi, we can write it as cosine of phi. But I put in a minus sign here because notice that the coordinate of this point right over here, the x value is negative. So that's what this minus sign is doing here. So now if you stare at this picture, you see that this length here, cosine 180 minus phi, must be the same as negative cosine phi. And the length of this side, sine of 180 minus phi, must equal sine of phi. So this diagram may help you to remember these two trig identities. One last trig identity, which is easy to remember, is the following. Look at our unit circle here. Angle theta. The length of this side is cosine of theta. The length of this side is sine of theta. Pythagorean theorem tells us that the length of this side squared plus the length of this side squared must equal the hypotenuse squared. In other words, length of this side cosine squared theta plus the length of this side squared, sine squared theta, must add up to the hypotenuse squared, 1 squared. So cosine squared theta plus sine squared theta equals 1. That's the last of our very useful trig identities. The final remark I want to make is the following. In physics, you're primarily going to be given the following situation, or analyzing the following situation. You have a triangle, you know the length of the hypotenuse, and you know the angle theta, and you're trying to determine what the lengths of these two sides are. And we've just seen that the length of this side here is h, the hypotenuse, times cosine of the angle, and the length of this side is h times sine of the angle. This is the case that you're usually going to encounter. But sometimes in physics, you may encounter the following situation, where you'll be given a triangle and you'll know the length of this side, let's call it A, the length of this side, call it B, and the length of the hypotenuse, call it C. So in some situations, you might know the lengths of these three sides. And what you want to do is determine what this angle is here, or maybe you want to know the sine of this angle or the cosine of that angle. Then in that situation, we can use the following. If I know the length of side A, B, and C of a right triangle, then the sine of this angle, theta, is given by B, which is the length of the side opposite to the angle, divided by the hypotenuse C. So sine of the angle theta is equal to B over C. Cosine of this angle theta is given by A, the adjacent side, over the hypotenuse, A over C. And finally, we define the tangent of this angle. We define it to be the sine of the angle divided by the cosine of the angle, which is simply equivalent to B over A. And that's about all you're going to need to know in your introductory physics class from basic trigonometry.